Hello everyone. Now our group will report the topic of memory. Through the previous study, we have some understanding of the concept, classification, and the function of the memory. And today, we will focus on this part of the working memory. We will report from the following three aspects. First, I will explain what working memory and how it works. Three aspects of brain thinking deserves attention. It includes attention, working memory, and long-term memory. And the so-called working memory refers to the system that people temporarily store information in the process of completing cognitive tasks. Working memory can be understood as a temporary psychological work platform on which people manipulate and assume information to help us understand the language, make decisions, and solve problems. Working memory can also be compared to a thinking blackboard, which can provide an inverse on which we can temporarily place information so that it emerges in our mind. The size of the workbench is limited, usually considered to have the size of 7 tracks. We usually can only focus on one thing on the workbench. If we multiply things, it may affect the word effect. If we have a lot of things think about at the same time, we will use the principle of attention here. Attention is controlled by a work memory. Attention is like a searchlight, emulating what we are focusing on right now. For example, now I'm focusing on writing instead of wonder what the dinner is or where to go as a weekend tomorrow. The size the workbench is also regularly cleaned up. And the working memory generally only remains information for a few seconds. But working memory also links to the necessity of long-term memory. When thinking, we can recall things from a long time ago. Effect they are all stored in long-term memory. Get information, you can come to help answer the questions. For example, to complete the task of 2 times 5 times 6, you must first remember that 2 times 4 equals to 8. The 5 times 6 equals to 30 in order to complete the above task. Working memory is not a single processing system composed of multiple components. It includes 4 components: psychological loop, visual spatial escape and the ethodic buffer, and the central execution system. Different components have different functions. Say that taking the multi-component model badly as an example, the central execution system is the control processing system, and the psychological loop and the visual spatial sketchpad and the impulse buffer as the short-term memory. And the central executive system is a control system that we should pay more attention to limit resource. And it's the most important concept of working memory. Visual spatial sketchpad is used to process visual and spatial information. For example, we see a landscape painting on the wall directly enters the visual space temper if we close our eyes and produce the representation of the painting from memory. Then this information enters the spatial temporary indirectly. And next, the psychological loop is used to process voice-based information. For example, when we reading text, it listens to other people's. It will involve the philological loop. Aesthetic buffer. It is a component used to integrate visual, spatial, and the verbal information. It's a space with limited computation. Use the integrate information from voice loops and the visual space templates. Above all, the information processing and the stage method of working memory plays a very important role in completing many complex cognitive activities such as learning, conclusion, reasoning, and language comprehension, and its continuous actions. Okay, this is all my view about what is working memory and how does it work. Okay, next Mia, please.
Hello, this is Mia. This part is to explore the important role of neuropsychology in working memory for Alan D. Baddeley. Okay, let's start with the question. How does Baddeley develop the concept of working memory with the help of neuropsychology? Broadly speaking, Baddeley drew many conclusions from clinical cases in neuropsychology, and concretely speaking, Baddeley has a thinking model like this. First, raise a question. Second, make an assumption. Third, use clinical cases to prove the assumption, and then came to a conclusion. We can see it from his four stages of working memory development. At the stage 1, let's look at the figure. It is the original version of working memory. So how did Badley get it? First, he asked about patients who had impaired short-term memory, but no more long-term memory. How could information get into long-term memory if the short-term memory system was impaired? And he assumed it is unlikely that the proposed short-term storage performed all the activities. And his clinical case, because at that time he had little access to clinical study, so he just turned undergraduate participants into simulated patients, and he got his first sketchy conclusion. He abandoned the concept of short-term memory and replaced it with working memory. It is the three-component model like the figure 1. And at the stage 2, we can see the second figure of working memory. Uh, it is modified version. And how did Betty get it? At this time, he paid more attention on phonological loops, so he asked what was phonological loops function, because the phonological loop play an important role in language processing. So he assumed whether a phonological loop limitation may lead to slower development of vocabulary in children. In his clinical case, he did a comparative study, and from that he got his conclusion. And this finding showed a direct link between temporary storage and long-term learning. At the stage 3, we can see in his third version, episodic buffer was added. Compared with the second version, he asked, was the three-component model capable of explaining performance on the working memory span task itself? So he assumed boldly, uh, maybe there is a fourth component to the model. His clinical case from two highly intelligent people but they were suffered from amnesia. From the case, he made sure there is a force component and a termed episodic buffer, which is a temporary storage system that was capable of maintaining information. Let's move to the stage 4. Basing on the stage 3, he found two questions. And his assumption is about the process of visual and language binding. And this time, he didn't refer to any clinical cases, but these questions appearing in the using of the third model led him to an area they had previously neglected. After his analysis, he proposed the fourth version of working memory. It is also the newest one. In short, what is said above is Baddeley's four stages of developing working memory under the help of neuropsychology, and I also got my own conclusion. First, neuropsychology plays a crucial role in the developing the concept of working memory for Baddeley and also for our own learning working memory. And we can learn Baddeley's thinking model to get our own conclusion in our later study. And we also need to notice sometimes finding a suited clinical case proving the assumption is not so easy, and collecting more cases or experimental data is needed to make the assumption more reasonable and for effective inductive reasoning. Okay, that's all. Thank you.
Okay, so what we mentioned before, working memory plays a very important role in our life. However, it also facing some issues such as the damage in temporal lobe or hippocampus. For whom are suffering this, they can't really recall certain memories. However, empirical research proves that interference and systematic working memory training can significantly improve it. Now, I'll share a research paper which talks about a computerized working memory training after stroke. And the research question of this article is, does the working memory training in adult patients with stroke has a significant effect? What is quite different from previous research are more focused on attention. Authors in this paper applied a computerized training method which focuses on working memory to interfere working memory of stroke patients. And for the research method, researchers compared pre and post training assessments between the treatment group and the passive control group, and also used the cognitive failure questionnaire, and it covered 5 tests I already stated in below. And now let's look at how do writers analyze the data. They use JMP, which is software to analyze the data. And let's look at the first table. We can see how researchers select the candidates. Those are the criteria for the researchers. They choose participants. Those are the inclusion and exclusion criteria. Okay, now let's move to next table. We can see the stroke candidate are under 65 years old. The sample size is 18, which all come from the stroke rehabilitation unit in the same hospital. And the age range of remaining 18 participants was between 34 and 65 years. The mean age of two groups is 54, and the standard deviation is 7.7 years. Post-event time was 12 to 36 months. The mean value is 20.1. The mean number of fulfilled training days in the 9 participants who complete all 20 days or more of training and thus were qualified for post-training assessments was 23. Standard deviation is 2.2. Okay, so now the next table is the tasks. Okay, so we can see we go over all the tasks. And then let's move to this table. Okay, it shows the mean value and standard deviations from raw data on the neuropsychological test and the self-rating scale. There were significant differences between groups on the working memory test. On span board, DigitSpan, the PASET, the ROF 2 and 7, the p-value of them are less than 0.05, and especially on the PASET and ROF 2 and 7. No treatment effects were found on Raven test, the Stroop test, or on the test of declarative memory. Compared to the test-retest differences in the control group, the treatment group improved 19% more on the span board test. This is equivalent to 1 SD or an ES, which is effect size of 0.83 in test-retest differences between groups. Then, improvements were also significant on the non-trained test for working memory and attention. To compare treatment studies, researchers calculated the ES on the raw scores from the PASET in each study. The mean ES over all 6 studies was 0.33. There was no significant treatment effect nor any trend for an improvement for the declarative memory task. Before training, the mean score in the Raven test was 15.5, and after training, 89% in the treatment group had a score of 16 to 18. There was a significant decrease in the self-rating scores regarding cognitive failure symptoms. The ES for the improvement, as measured by the scores from the CFQ, was 0.80 post-intervention, which suggests a strong clinical effect. And after the research, writers conclude that more than 1 year after a stroke, systematic working memory training can significantly improve working memory and attention. However, let's look at the limitation of the research. The number of the participants is quite small and only had the passive control group. Maybe in the future study, we need a larger group and both passive and active control group. And these are the reference our groups cited. And in the end of the sharing, I would like to say, why do we need to learn how working memory process? For educators like us, we could help students to find a scientific way to learn, to memory, to deal with the problems that they might be facing. And for psychologists, they could cooperate with neuroscientists to help others who are suffering nervous damage, such as stroke or something else, and apply this in the clinic. And that will be very helpful. Okay, so that's all for my presentation and all for our group's presentation. Thank you.